All right, here comes page 3. These can be a little bit confusing, so make sure to read closely. They want us to find the circumcenter. That's the point of concurrency. Remember, a point of concurrency is when we have 3 lines all intersecting at one point. This is the point of concurrency. But we need all the perpendicular bisectors. So we need to be able to cut some lines in half. This symbol means perpendicular, means we need to make 90-degree intersections. But the good part is if we know where 2 of the lines intersect, then we know the third one's going to hit the same point. All right? They gave us points to graph, but I was nice and I already graphed the object for you. Now just realize if we're trying to bisect the sides, 2 of these sides is actually pretty easy. Horizontal and vertical lines will be easy to cut in half because we can actually count how long they are and cut them in half pretty simple. So if this is 1, 2, 3, 4, 5, 6, 7, 8 units long, cutting it in half will be pretty easy. We'll do that at the 4th unit mark. And if I got to make 90 degrees with a horizontal line, that's easy. I'll make a vertical line. So I know I have a perpendicular bisector there. The other easy one will be to do the vertical line. This one happens to be 1, 2, 3, 4, 5, 6 units long. So I'll cut it in half at the 3rd unit. And here, 90 degrees will be easy as well. If you see where they intersect, I don't need to do the 3rd one because it will also intersect right there. All I need to know is what are the coordinates. As long as I can figure out what the coordinates of that point are, then I have found the circumcenter, the point of concurrency for all of the perpendicular bisectors. Well, the coordinates of that point, I would go to the right one and up 2 to get there. Looks like a very complicated problem, but if you have a good attack plan, it's not that bad. Okay, so in here, there's a big problem on the quiz and test about that. It looks just like this. Triangle ABC, we have these 3 segments, which are all medians. These lines here are all medians. That means the point is a midpoint. It's connected to the opposite vertex. So each of these have to be midpoints. But this is an application of what's called the centroid theorem. That means each one of these medians is going to be cut into a smaller piece and a longer piece. The smaller piece will be 1/3 of the total, and the longer piece will be 2/3 of the total. If you put them all together, we got 3/3. That means all of the pieces. So let's look what they gave us. XA. XA is 36. XA is the entire median. If I break that into thirds, if XA is 36, each of the thirds would have to be 12. It's just dividing it by 3. Well, if we want to know, we're going to find a bunch of measurements here. If XA is 36, this small piece will be 1 of the thirds. That means XO has got to be 12. The longer piece will be 2 of the thirds. 12 and 12 makes 24. They said that OY is 10. OY, that's 10. Well, that's the smallest piece. That's 1 of the thirds. That means each third is 10. That means the longer piece will be 2 of those thirds. That's actually what they're asking us to find is BO, which would be 20, and by, the whole thing, which would be all 3/3, would be 30. But here's the answer they're looking for. Just be aware, on a quiz and test, I'd ask you to find them all. And the last problem on this page, GJ and IJ are angle bisectors. All right, if we had the other angle bisector, it would hit point J as well. Try to remember the point of concurrency for this situation is called the incenter. That means there's some imaginary circle that fits perfectly on the inside and touches all 3 sides. All right, so JK is a radius for that circle. They want us to find the distance from J to GH. They want us to find this distance. Well, I don't know if you know about circles, but every radius of the same circle has to be equal. So if JK is 42.9, this problem looks complicated, but it's over. The distance from J to GH is also 42.9. That is the 3rd page of the test review.